Hello student, welcome back. We are going to start today's session. It is lecture 0 that will give you the idea about the subject and how it is mapped with CO and POs and objective outcome means about the syllabus and everything we are discussing in this lecture. Microcontroller and embedded systems, ETCE, MCES, S5, Shongita Roy, Electronics and Communication Engineering Department, Narula Institute of Technology. Course name, Microcontroller and Embedded System. Course code, ETCE, MCES, S5. Prerequisites, Knowledge in Digital Electronics, Credit 3. Course objective, to introduce students with Assembly Language Program 8051 microcontroller, to familiarize the students with the programming and interfacing of microcontrollers, to provide strong foundation for designing real-world applications using microcontrollers. Course outcome. CO1, able to compose arithmetic and logical operations program based on concept of assembly language programming for 8-bit and 16-bit operation using 8051 controller. CO2, able to interpret the interfacing technique of 8051 microcontroller instructions for glowing LEDs according to control stepper motor, creating interfaces 7-segment display and to display string keyboard operation, etc. Able to analyze the concept related to memory, I/O organization, able to compile timer, counter, interpret handling, program based on the concept of assembly language programming with the help of 8051 microcontroller. Now the program outcomes as defined by NBA, PO, engineering knowledge, apply the knowledge of mathematics, science, engineering fundamentals, and an engineering specialization to the solution of complex engineering problems. Number 2, problem analysis. Identify, formulate, review, research literature and analyze complex engineering problems, reaching substantiated conclusions using first principle of mathematics, natural sciences and engineering sciences. Number 3, design and development of solutions. Design solution for complex engineering problems and design system concepts or process that meet the specified need with appropriate consideration for the public health and safety and the cultural, societal and environmental consideration. Number 4, conduct investigation of complex problems. Use research-based knowledge and research methods include design of experiments, analysis and interpretation of data, and synthesis of the information to provide valid conclusion. Number 5, modern tool usage. Create, select and apply appropriate techniques, resource and modern engineering and IT tools, including prediction and modeling to complex engineering activities with a understanding of the limitation. Number 6, the engineer and society. Apply reasoning formation by the contextual knowledge to access societal health, safety, legal and cultural issues and consequent responsibilities relevant to the professional engineering practice. Seven, environment and substantiality. Understand the impact of the professional engineering solution in societal and environmental context and demonstrate the knowledge of and need for substantial development. 8, ethics. Apply ethical principles and commit to the professional ethics and responsibilities and norms of the engineering practice. 9, individual and teamwork. Function effectively as an individual and as a member or leader in diverse team and in multidisciplinary settings. Number 10, communication. Communicate effectively on complex engineering activities with the engineering community and with society at large, such as being able to comprehend and write effective reports and design documentation make effective presentation and give and receive clear instructions. 11. Project management and finance. Demonstrate knowledge and understanding of the engineering and management principle and apply these to one's own work as a member and leader in a team to manage projects and in multidisciplinary environments. 12. Lifelong learning. Recognize the need for and have the preparation and ability to engage in independent and lifelong learning in the best broadcast context of technological change. Now, this is the mapping of course, objective, and these POs. So, it is known as COPO mapping. So, already in the earlier, this is the PO, and earlier it was COs. These were the COs, and how these are mapped, it is shown in this table. So this is the COPO mapping. 3 is the best mapping, 2 is the good mapping, 1 is the below mapping, and 0 means no mapping at all. So no mapping at all will not be there. There is always some mapping between them. So thank you for this presentation, but still we are going to do something. So we are going to show, this is the lesson plan. Already you have seen, this is the course code, weightage of the subject. So this is the course outcome, prerequisite. Now this is the syllabus. This has 5 modules over there. So in the first module, it is about microcontroller architecture 8051. Second module, it is 8051 address modes and instruction. Third module, 8051 assembly language programming. Then fourth is introduction to embedded system, and fifth, it is the elementary idea of robotics, and these are the references. So this is all about the subject, and we will meet in the class. So we are ending the session over there.